The question is, why do we have N-1 KCL equations in a circuit with N nodes? So it is quite interesting question actually, because KCL is applied at a node. Because we have N nodes, we can able to write N KCL equations. But in the circuit analysis point of view, if you take, we will leave about the ground node. Ground is also principal node. Okay, and how many principal nodes are there, we will count in the circuit. And for example, that is capital N, including the ground. But we will leave the ground. Instead of applying the KVL at the ground, we go for remaining principal nodes. That means we go for remaining N-1 nodes and we will apply KCLs. Then we will get a N-1 KCL equations. What is the reason for leaving the principal node ground without application of the KCL? That is what we are going to discuss in this particular thing. Okay, so to explain this one, just I am taking one circuit. So here I am taking KCL at all the 4 nodes in the beginning. So KCL at node 1 I am representing like this. Numbers with circles are representing the nodes. So I have 4 nodes and just numbers are indicating the branches. Okay, so KCL at node 1 I am applying by the indication of the currents. Okay, so currents I will indicate with another color icon. Okay, now this is the final circuit. So what I am going to do, in the sense, I am going to apply KCLs at all the nodes. Then what we will get, you see. So at node 1, 3 currents are involved and I am taking algebraic sum of all the leaving currents is equal to 0. So at node 1 I1 current is entering. So to make it leave, I am taking -1 and minus I1, then plus I4 and plus I6 is equal to 0. Then I am taking KCL at node 2. KCL at node 2 I am taking. Okay. Then at node 2 also 3 branches are connected. So 3 currents will be there. And I2 current is entering. So I am taking minus I2. And I4 current is also entering. So I am taking minus I4. And I5 is leaving. So that I am taking plus I5 is equal to 0. Then I am going to take KCL at node 3. KCL at node 3 I am going to take. Then what I am going to get here, at node 3 also 3 branches are involved, 2 resistors and 1 current source, and 3 currents are there. I3 is entering, I am taking minus I3. I5 is also entering, I am taking minus I5. I6 is also entering, so I am taking minus I6 is equal to 0. Then finally I am going to take KCL at node 4 also. KCL at node 4 also. So what I am going to get at node 4. Node 4 is also involving 3 branches, 2 current sources and 1 resistor. And I1 is leaving, so I am taking plus I1. I2 is also leaving, plus I2. And I3 is also leaving, I am taking plus I3 is equal to 0. This is what I got 3 current equations. Sorry, 3 KCL equations with this particular circuit. Then interestingly, what I am going to do is, just I will take addition of first 3 KCL equations. Okay, these are the first 3 KCL equations are there. I am taking the addition of all those 3. Then what I am going to get? Otherwise, I will take just equation 1, equation 2, equation 3 and it is equation 4. So simply I will take equation 1 plus equation 2 plus equation 3. Then what I am going to get? Left side, here minus I1 is there. And do we have any I1 term? No. So minus I1. Then here I4 is there. But in the second equation we have minus I4. So these two will be cancelled. Then here I6 is there. And in the third equation we have minus I6. So this will also be cancelled. From the second equation I have minus I2. So I am writing that minus I2. And in the second equation I5 is there. But in the third equation minus I5 is there. These two will be cancelled. So in the third equation just we have left with minus I3 is equal to 0. Now this is a new equation. This equation came from the addition of first three equations. And surprisingly, and I'm taking this addition of three equations, I'm taking as the fifth equation, and surprisingly, now you observe this one along with the fourth equation which was applied at node 4. You see carefully, node 4 KCL equation is I1 plus I2 plus I3 is equal to 0. And now equation 5, this is because of the addition of first three equations which are applied at the nodes 1, 2, 3. We got here minus I1, minus I2 and minus I3 is equal to 0. It is nothing but equation 4 only if you multiply with minus. That means from the first three equations only, by the addition we got the fourth equation. So there is no requirement of getting the fourth KCL equation at the node 4. 3 are enough. Okay, so why it is happening like this? So this is one surface where we have this particular node 4, and I am taking another surface. I am taking the another surface which is involving remaining 3 nodes. Okay, so what we can able to tell from this one? The currents which are leaving the surface which is involving node 4 are the same currents which are entering into these 3 nodes. You can able to observe here. At node 4, what are the currents are leaving? I1 and I2 and I3. These are the 3 currents leaving node 4. Or now I am telling in a different way, I1, I2, I3 are the 3 currents leaving the surface involving the node 4. And the same currents, these are leaving the surface having the node 4, and these 3, I1, I2, I3, entering the another surface nodes 1, 2, 3. 1, 2, 3. So this is what we got in the previous case. Okay, so this is the reason what is the necessity of just applying at n-1 nodes only, and we can able to leave this ground node or reference node, and you no need to take this fourth node as the ground node. You can take any of the 4 nodes as the ground or reference. Okay, so it is required to apply at the remaining principal nodes. You have to apply the KCL. That is why you are getting for n nodes. It is required to have just n-1 KCL equations. Thank you.